My little brother asked me a question that sounded simple. He said, "Is the universe finite?" And I said, "From our perspective, it kind of feels infinite," which was my first mistake because children do not accept half answers. They collect them. Then they throw them back at you like tiny philosophers with homework. So he asked, if the universe is expanding, what is it expanding into? And before I could breathe, he added, "And if matter and energy can be created or destroyed, where is this new space coming from?" Excuse me? Sir, I thought we were having a normal conversation, but that question is actually one of the strangest questions in cosmology. Because the way most of us imagine the universe is expanding is wrong. We imagine an explosion, something tiny burst outward, galaxies flew away, everything spread into empty darkness, like glitter thrown across a black room. But the problem is, there may not be a room. The universe is not expanding into space, space itself is expanding. And yes, that sounds like the universe hired a lawyer, but that is the actual idea. When scientists say the universe is expanding, they do not mean galaxies are all flying through space from one central point. They mean the distance between faraway galaxies is increasing because the space between them is stretching. Not your body, not Earth, not solar system, not even our galaxy in the ordinary everyday way. Gravity holds here nearby things together. Your chair is not secretly expanding when you leave the room. Although, if it is, please let me know. That chair knows too much. Cosmic expansion mostly matters across enormous distances. Between galaxy clusters, across scales so big that numbers stop feeling like numbers and start feeling like threads. Now, here is the part that messes with the brain. If space is expanding, what is outside it? Maybe nothing. Not empty space, not a black void, not a bigger universe container holding our universes like leftovers in a fridge. Maybe nothing. Because outside is a word that only makes sense when space already exists. You can go outside a house because there is more space outside around the house. You can go outside a car because the car is inside a world. But the universe is not a car. The universe includes space. So asking what it expands into may be like asking, what is the north of the North Pole? The question feels normal, but the direction stops working. Now, does that mean the universe is infinite? We do not know. That is the part people do not say loudly enough. The observable universe is finite. That means there is a limit to what we can see because light has only had a certain amount of time to reach us. The universe is about 13.8 billion years old. But the observable universe is not only 13.8 billion light years across because space has been expanding while the light was traveling. So the observable universe is roughly 92 to 93 billion light years across, which is already ridiculous. But that is only the part we can observe. The whole universe could be much larger. It could be infinite or it could be finite in a way that has no edge. That sounds impossible until you think about Earth. Earth's surface is finite, but if you walk in one direction long enough, you do not reach a glowing wall that says, "End of Earth, please turn around." You just keep going. You can travel around a finite surface without finding an edge. Now, space is not exactly Earth's surface, but the point is this. Finite does not always mean bordered, and infinite does not always mean expanding into something. Even an infinite universe can expand. That sounds illegal, so let's shrink it down. Imagine an infinite number line. It already goes forever. Now, double the distance between every number. 1 becomes 2, 2 becomes 4, 3 becomes 6. Everything is farther apart. The line expanded, but it did not need extra space outside itself. It was already infinite. What changed was the distance between points. That is closer to what the cosmic expansion means. The universe is not necessarily growing into a bigger room. The distance inside the universe are changing. Now let's go back to my brother's second question. If matter and energy cannot be created or destroyed, then where is the new space coming from? This is where the school version of physics starts sweating. Because matter and energy cannot be created or destroyed is a good rule. It works in everyday life. Burn wood and the matter does not vanish. It becomes ash, smoke, gases, heat and light. Charge your phone, drain your phone, heat water, cool a drink. Energy changes form, energy moves around, but the whole universe is not an everyday object. The universe is not a box sitting inside a bigger box. In general relativity, space and time are not just the background. They are part of the system. They can bend, they can stretch, they can evolve. And when space-time itself changes, the idea of total energy of the whole universe becomes weird. Energy is conserved locally. That means in your kitchen, your car, your body, your phone, your lab. Physics is still keeping receipts. Energy does not just disappear because it feels shy, but across the entire expanding universe, there may not be one simple cosmic total that works the way we expect. The universe does not hand us a neat bill at the end saying, before expansion this much energy, after expansion same amount. Thank you for shopping at reality. It's not that simple. One example is light. As light travels through expanding space, its wavelength gets stretched. That is called redshift. Longer wavelength means lower energy. So if a photon loses energy as the universe expands, where did that energy go? That question sounds like it should have a simple answer. It does not. It is not like the photon paid rent to space. It's not like the missing energy is sitting in a cosmic savings account. In an expanding universe, the energy of light can decrease because the geometry of space-time has changed. And I know, that sounds rude, but the universe is not famous for asking permissions. Dark energy makes this even stranger. Dark energy is the name scientists give to whatever seems to be causing the expansion of the universe to speed up. We do not fully know what it is. That is important. Dark energy is not a solved character. It is more like the universe left a sticky note saying, something is making expansion accelerate. Good luck. If dark energy behaves like a cosmological constant, then its density stays roughly the same as space expands. So, as the universe gets bigger, there is more space. More space with the same dark energy density sounds more like total dark energy, which sounds like energy appearing. And that is where the simple sentence energy cannot be created or destroyed starts looking nervous. But no, this does not mean you can plug your laptop into the expansion of space. Unfortunately, I checked emotionally. It means the rule is more subtle than the classroom version. Energy conservation works beautifully in ordinary situations, but the entire universe is not an ordinary situation. The stage itself is changing, and when the stage changes, counting everything on the stage becomes harder. Now, what about the Big Bang? People often imagine Big Bang as an explosion happening somewhere. Like the universe was a tiny bomb in empty space. Then boom, matter flew outward. But the Big Bang was not an explosion inside space. It was an early universe itself in a hot, dense state. Space was already part of the story. There was no outside room waiting for the explosion. There was no center that everything flew away from. Everywhere was involved. That is the part that makes your brain quietly close the tab. The Big Bang did not happen at one point in space. It happened everywhere. Every place in the universe today was once part of that hot, dense early universe. Your room was there, not as your room. Please do not imagine your couch surviving the Big Bang. But the space that eventually became your room was part of the same expanding universe. So when someone asks, what is the universe expanding into? The best answer might be maybe nothing. Not because nothing is boring, but because into might be the wrong word. The universe is not an object moving through space. The universe includes space. This is why the question feels so uncomfortable. Our brains are built for objects inside places. A cup on a table, a phone in a pocket, a shoe under the bed, a sibling asking impossible questions while you are trying to live peacefully. Everything we know sits inside something else. So when we hear the universe is expanding, we immediately look for the container. But the universe may be the container. Or worse, it may be the thing that makes the container possible. That is where language starts breaking. What does outside mean if space itself is part of the universe? What does before mean if time itself is part of the universe? What does total energy mean if the entire space-time is changing? Those are not stupid questions. They are the exact questions that show us where human intuition stops working. So here's the simplest version. The observable universe is finite. The whole universe may be finite or infinite. The universe is expanding, but probably not into anything. Space itself is stretching. Matter is not being created just because the distance between galaxies grow. Energy is conserved locally, but the total energy of the entire expanding universe is not as simple as the school version makes it sound. And the new space is not being poured in from somewhere. Space is not a substance filling a jar. It is the geometry that tells distance how to behave. The universe is not expanding into a place, it is expanding. The meaning of place. And that is the part I cannot stop thinking about. Maybe the universe is not mysterious because it is far away. Maybe it is mysterious because the moment you ask one simple question, our words start running out. So, if the universe is expanding and there may be no outside, and the universe itself can grow without entering anything, then what are we actually inside? A universe or the thing that makes inside possible?